Hello, I'm Alessia Marelli, the Chief Technology Officer of DNA Argo, and today I would like to talk about the edit distance. Edit distance is the metric used in the DNA data storage channel. It is a very important metric because it's very useful, let me say necessary, in algorithms such as error correction code, but also in another part of DNA pipeline, such as clustering or trace reconstruction. DNA data storage channel is an IDS channel, which means that the number kind of errors that can occur are insertion, deletion, and substitution, which is quite different from the standard storage channel where just substitution can happen, and the matrix used is the emit distance. In IDS channel, the matrix we need to use is the Levenshtein distance, also called edit distance. While it is quite easy to understand how to compute it, the algorithm used to compute actually it and to recovering the message when dealing with this distance, it's much harder. So let me make an example. Here we have two strings of oligonucleotides where the kind of are the IDS channel error, and we want to compute the edit distance between these two strings. So the edit distance actually is the number of steps that we need to perform when starting from one string and reaching the second one. So in this case, starting from one string and in order to reach the second one, we need to delete a C, so step one. We need to replace an A with a G, so step two. And then we need to insert a T at the end of the string. So actually the edit distance between these two strings is 3. In order to compute the edit distance, we need to use a known dynamic programming algorithm, also known as Wagner-Fisher algorithm. This algorithm is used when computing the edit distance between two strings, but in our case, the DNA sequences are actually two strings, where the alphabet is just composed by the 4 letters, the A, C, G, T. So first of all, we have two strings of length n and length m, and we need to evaluate a matrix where the size is n plus 1 times n plus 1, and the matrix is filled according to a particular formula. So suppose that you want to compute the edit distance between two strings. The one is Paolo and the second one is Paolo with exclamation at the end, and the first P is a capital P. So we need to initialize the matrix, and the matrix whose size is 6 plus 1, so 7 rows, times 5 plus 1, so 6 columns. The first row and the first column are filled up, initialized in an increasing order. So we need to fill it up all the cells of the matrix, and then at the end, in the one here filled up with yellow, we will have the actual distance between these two strings. So how we will fill up the matrix? Basically, each cell will be computed as follows. So if the two characters that we are comparing are the same, we will give a 1 to a 0 as penalty to that particular cell. If the values are different, we will give a penalty, which is this as a 1. Then each cell will take into account the value on the diagonal plus the penalty, the value on the left-hand side, and the value on the upper part. But let me go ahead with an example which will make it clear. So taking again our example, we want to compute the edit distance between Paolo and Paolo with capital P and exclamation at the end. We want to fill up the first cell. So the first cell will be the minimum on the value on the diagonal, on the left-hand side, and on the upper part. So on the diagonal, we have a 0, but we need to add the penalty. The penalty, when comparing with P, with capital P, is 1 because the two letters quite different. So 0 plus 1, which is 1. Then we have the value on the left-hand side, which is 1 plus 1, which is 2, and then the value on the upper part, which is 1 plus 1, which is 2. So the value on this cell will be the minimum among 0 plus 1, 1, 2, and 2, which is actually a 1. Then we will go ahead with the second one. So in the second case, we will take the value on the diagonal, which is a 1, and then the comparison between capital P and A is still different. So we will still need a penalty, which is 1. So this value will be 1 plus 1, which is 2. We will take the value on the left-hand side, 1 plus 1, which is 2, and the value on the upper part, which is 2 plus 1, which is 3. So the value on that cell will be the minimum among 2, 3, and 2, which is 2. Then we will go ahead and fill it up all the cells of the matrix. Let me make here another example in the red cell. So here we are comparing A with A. So we will need to take the value on the diagonal, which is 1, and add the penalty. But the penalty in this case, since we are comparing two letters that are the same, is 0. So 1 plus 0, which is 1. Then we will take the value on the left-hand side, 2 plus 1, which is 3, and the value on the upper part, 2 plus 1, which is 3. So the value in the red cell will be the minimum among 1, 3, and 3, which is a 1. Filling it up all the matrices, we will reach the last cell, which is 2. So actually the added distance between Paolo and Paolo with capital letter and exclamation is 2, which is quite easy to understand because it's the number of steps that we need to perform starting from Paolo and reaching Paolo with capital letter and exclamation, where the difference are 2 letters basically. What happens when dealing with added distance in this IDS channel? What happens, which were not used generally in standard storage system, is that the errors are not unique. This means that the same outcome can be explained with different steps of errors. And then the errors are not additive, which means the different type of errors can sometimes cancel each other. Or in other words, that the same outcome can be explained with fewer errors. But let me make some example that will make these two assumptions clearer. So if we see what happens on the left-hand side is what actually occurred, so the events that has been generated. And then on the right-hand side, we have the events that have been read. So we have a first string, which is T, A, and G, and then some error occurred. So at the end, this is what we received. But what the kind of errors that actually happened is that an A has been deleted, and then an A has been inserted. So actually there were 2 errors, an insertion and a deletion. But what happens at the end is that we wanted to write T, A, G, but actually we read T, A, G. So what happens is that one deletion followed by one insertion in this case result in no error, because actually the added distance between these two strings is 0. So no error occurred. Here we have another example. Still on the left hand side we have what has actually happened in the channel, and on the right hand side we have what the events that has been read. So we wanted to write TACGT. We had a deletion and then we had an insertion. What we have on the right hand side is that actually a TACGT has been read and TACCT. The added distance between these two strings is 1, and it can be explained by just one substitution. A C became C. So in this case, what actually happened, which was two errors, are instead explained as just one error, just one substitution. We can go ahead with this kind of example. So in this case, we have one insertion, here one deletion and one substitution, but the actual distance between what has been read is just 2, and it can be just explained with the deletion, that is what actually really happened, but just one insertion here. Here we have another example. So in this case, we have 3 substitution, but at the end, the edit distance between what has been read is just 2, and it can be just explained as one insertion here and one deletion here. So when we compute the edit distance, basically it's the minimum, remember that it's the minimum number of steps that we need to perform from going from one string to another, and that's why what really happened in the channel can be explained with fewer errors. Going ahead, here in this case, what happens really is one deletion and then one insertion. We have actually the edit distance of 2, but in order to going from one string to another string, we can follow different paths. One is the actually that really happened, so the deletion and insertion, but another possibility is the 2 substitution. So the same path, because they have the same edit distance, can be explained in different ways in this particular channel. So thank you very much. This is a quick overview of the edit distance. Hope you enjoyed it.